Emily.
And I'm Kimberly.
And we're from the Knee Project. And we are going to ramp up the fun today with this activity brought to you by our friends from the Shell Summer Intern Program. And we are going to make a mini roller coaster or explore the ramps and hills and friction forces that a roller coaster might explore. And we're going to talk about how kinetic and potential energy are constantly being transformed in a roller coaster. So, before we start, let's go over some safety. Kim, you want to cover that?
Absolutely. All right, so as we're going to discuss kind of the ramp construction procedure, you'll be using scissors, maybe a box cutter. Be mindful because these are sharp, so you'll want to be careful as you're cutting and setting up your ramp. Use caution, and then just be mindful of your area, depending what ball you're using or marble. You don't want it to fall and then slip on it. So those are a few safety concerns that we'll want to keep an eye on throughout.
And for this activity, we're going to use, like Kim mentioned, we're going to be using a box, and you're going to need to construct the box. We'll go over that in a second. But in order to construct the box, you're going to need, obviously, a once empty box, right? You're going to need some scissors, like she mentioned, something sharp. You're going to need some tape, because we're going to need to tape some of the pieces together. A marker is handy so that you can label the sides of your box. And you're going to need a ball. You can use a golf ball, you can use a big ball, a little ball, a bouncy ball, whatever you have handy. And you're going to need a blanket or a small piece of fabric for our very final step. So gather up all of those things. And the first part, and maybe the hardest part, is going to be constructing your ramp. And we've already constructed it for you. And so this was originally a 4-sided box. And for this activity, we ended up cutting one side of the box so that it was a square that came to a flat piece. So you literally cut one corner of the box here. We also, for length and space that we're working in, we actually cut off one of the panels of the box so that we can have a shorter ramp. So once you get a piece of flat cardboard, you're going to need to tape the edges together. And it sometimes is helpful to kind of tilt the edges in a little bit so that your ball has a natural ramp and path to follow, and your ball doesn't go flying off the sides. So the tape kind of helps that process. The other thing that we have to help us out here are some empty boxes, and you could use stacks of books, but you want to have 2 equally sized objects that you would place under your ramp so that you can complete the activity and look at how the ball travels just like a car would travel on the roller coaster. So once you've got your ramp set up, you are good to go. And we're going to explore energy in motion. So first things first is we're going to start with our ramp, and this is a 2-person job here. You might need an extra set of hands. We're going to start with this so that we have end 1 of our box and end 2 of our box ramp about the same height. And we want to try and make it so that it's not a square in the center, and our ball follows kind of a rampy pattern and doesn't go doot, doot, doot. We want it to kind of flow up and down. So first thing we're going to do is, with our ends about equally spaced, we're going to start with our ball at the top of end 1 of our box. And what we're going to do is we're going to drop it and watch it roll up towards side 2. And what we want to do is we want to look at how fast the ball moves and how far the ball moves. And we're going to compare that to different positions of the ramp, both on this side and on this side, to see how, when we change the height of different ends of the ramp and the flatness of the ramp, how the ball responds, and kind of translate that to how a roller coaster car would travel in the same situation. So the first thing we'll do is we'll start with them at the same height, and what I'm going to do is I'm going to let it go towards Kim's fingers on side 2. Okay, and Kim showed us that it didn't make it the whole way up. I started the ball about here. It didn't make it all the way up to the same spot on side 2. Why is that? We'll talk about that in a second. Okay? Next step is we're going to try and lift side 2 up so that it's a little higher than side 1. So all we've done is we've just shifted the ramp up a little bit towards Kim. So I'm going to do the same process, and we're going to compare. Do we think the ball moves faster? Do we think it moves the same way? Do we think it goes as far or farther? Or do we think it doesn't go nearly as far? So let's take a look. Oh, so what do we see with Kim's finger? You can use a marker instead if you'd like to mark your spots. We can see that this ball didn't travel as far as it did the first time when the hills were equal size. So if the second hill on your roller coaster is higher, we could be in for some problems if we want to keep our roller coaster moving, okay? Step 3 is we want to actually put them back closer to same height, but I'm actually going to scoot line or side 1 so that it's a little flatter and it's a little higher than side 2. And we're going to watch how our ball travels. Ooh, okay. So this time it almost made it the whole way up to the other side and could have possibly gone off the other side. So if our first hill is taller than our second hill, it's better for our ball to keep moving. And it does end up moving a little bit faster. The last piece that we're going to try and do here is we're going to try and lift side 1 up higher and flatten side 2 out as much as we can here. There we go. And we're going to watch how our ball moves and watch how fast it goes. Whew, definitely went faster and it definitely went further. Okay, so the last step that we want to follow here, and our ramp is falling down, you'll probably have the same issues, is we're going to actually take a piece of fabric and lay it down on our ramp. I'm going to actually lay it the whole way down, parts there, and we're going to repeat it so that step 1 or side 1 is higher and side 2 is a little flat. And it might need to come off the box like I'm doing here. That's totally good. And we're going to watch how the blanket or the felt affects the movement of the ball. Definitely went as far, but it definitely went a lot slower. So how does this relate to a roller coaster? Well, when we're talking about a roller coaster, if you've ever ridden one of those, roller coasters have a series of hills. And as the car, in this case we're using a ball, as the ball travels up and down the hills, like the car would travel up and down the hills in the roller coaster, it's transforming from motion energy or kinetic energy to potential energy at the top of the hill, and to motion energy as it moves down the hill, and then potential energy again at the bottom of the hill, and kinetic energy and potential energy, and it's constantly doing that transformation as it moves up and down. Now, as we saw in our first step, we would like our hills to follow a progression in decreasing height order, usually. And why is that? If our roller coaster has our first hill being the tallest hill and the second hill being slightly less tall, the forward motion is going to continue like we saw in steps 3, where if our second hill, if we hold it up here, and our second hill is higher than our first hill, our ball is not going to go nearly as far up. Nobody wants to ride a roller coaster where you just fall down the first hill and stop at the bottom of the second. You wouldn't have any fun. If our first hill is taller than our second hill, our ball is going to be able to keep moving and move onward and forward, because as a moving object travels, it's going to stay in motion, but it's always going to lose a little bit of its forward motion because some energy is lost in its transformation. So what is that force that causes it to lose some of its energy? And this ball is feeling not just some forces from the box, but it's also feeling some forces from the air that's hitting the ball as it's moving. We call that force friction. And if you've ever ridden a roller coaster, you probably felt the force of the air. We call that air resistance or friction from the air pushing back on your face. And it causes your face to get deformed and change shapes, and your cheeks might flap a little bit in the breeze and you might feel some tears. But that force of friction that opposes the forward motion of the car is going to cause it to lose a little bit of its motion as it moves on to its next hill. That's why we need to have our first hill be taller than our second hill, and our second hill be taller than our third hill. And as we saw, friction is going to help slow that ride down, but if we keep those hills in order from tallest to shortest, we need something bigger to slow that ride down at the end. And in this case, we used a blanket. But on a real roller coaster, what we saw when the bottom was flat and the top was high, it's gonna keep on going for a while. So if we don't have another force to halt that forward motion of the car and slow that energy transformation down, that ball, or in this case a roller coaster car, is going to keep on moving. So we need another force to bring that car to a halt. So next time you ride a roller coaster, think about all of the transformations you're going through, not just with your face in the picture after you hit that big hill, but also in the transformation of energy as your roller coaster car travels from start to finish. Thanks.